Assalamualaikum warahmatullahi wabarakatuh and hello everyone. Welcome back to our class. Today we will discuss about Coulomb's law. Like I mentioned earlier, we have three parts for EMT, which is a electrostatic, magnetostatic, and as well as time varying field. For the first part, okay, to find the electric field intensity, we can use two methods, which is the first one, the Coulomb's law, and the second method is a Gauss law. Coulomb's law is a universal method that can be used to solve the various type of charge conditions. Well, as an overview, an electrostatic field is produced by a static charge distribution. Please remember this important fact. Okay, when we have the static charge, it will produce electrostatic field. Next, a magnetostatic field is produced by the moving charge on a constant current flow, or well known as a DC currents. Okay, this is when the static charge start to move with a constant velocity. And the third part, we have AC currents. AC current will produce the electromagnetic field. Okay, this is a electromagnetic field. This is just a simple illustration, but in the real application, the field will be more complex. So we just sketch the field as electric field, okay, which isolate at one directions, and then we have magnetic field isolate at one axis, actually one x-axis, another one y-axis, and vice versa. And the propagation direction is normally at z direction, but it can be changed. It depends on the situations. But here, I would like to stress that the propagation directions, the isolation between these two fields is always perpendicular each other. Okay, the propagation direction is here, and the isolation is going up and going in these directions. So it's always perpendicular. For static charge, we have whether the positive charge or negative charge. The positive charge, okay, we have the field going out from the charge, represented by the arrow. And then we have negative charge, the field is going in. For the magnetic field, we have the north and south poles. Okay, so we have the flux going from the north to the south. It's just like a loop, a complete loop. And this is a solenoid. Electric charge, the symbol is Q and the unit is Coulombs. Electric charge can be found first on a point, we call as a point charge. Second, along a line. Let's say we have a conductor with a negligible radius, and the line it consists of a charge, so we can call as a line charge. And then we have a surface. A surface means that it is very thin and the charge is distributed only on the surface of the object. For example, I have a ball or spear, and the space only accumulated on the surface of the spear. So we call it as a surface charge. And then in a volume, okay, let's say I have a cylinder and the cylinder contains a full of charge, so we call as a volume charge, or a combination of the above distribution. So that means when we have a charge, so it depends on the condition of the charge, how the charge is arranged. Okay, the arrangement of charge will have a different definitions and different analysis to find the electric field intensity. First, a point charge. For example, okay, a point charge is a charge so small compared to the distance. For example, we have a faraway star. If you see towards star, you can only see just a dot of light. So we can consider as a point charge. And the distance between the star to the earth is very far away. Next, a line charge. A line charge where the charge distribution along a thin line and the line is very long. Okay, let's say sometime we can define a charge system into two different conditions. For example, okay, let's say I have a sphere charge. Okay, a sphere charge when a sphere contains a charge inside. Okay, so we can call as a volume charge. Right. But let's say if I have a sphere charge, but I want to find the electric field intensity that is located very far from the sphere, where the distance between the sphere and also the point of interest is much bigger compared to the radius of the sphere. So we can consider the sphere as a point charge system. Same apply with let's say a transmission line. Let's say, okay, when we want to find the electric field intensity, okay, located near the transmission line, so we can say that the distance between the point of interest with our transmission line is significant. Means the distance compared to the radius of the transmission line is significant. So we can see the transmission line as a volume charge system. But what happens if I want to find the E field very far away from the transmission line? So we can see that the transmission line seen like a line charge, especially when the line is very long. So we can use a line charge system. So how to define a line charge? Let's say the line contains a charge system which have a uniform distributions. So we can find a line charge density given by these expressions. So the line charge is written as rho L, and the rho L is basically the delta Q divided by delta L. Delta Q is a sample of charge divided by the sample of length, where delta L is approaching 0. It's very small. So the rho L is basically the charge density when the situation is very small, and the unit is Coulomb per meter. Let's say I have a charge, total charge Q inside the line, and I have the length of L. So I can find the total, actually the line charge density by dividing Q with the total length, Q over L. So I got L. If we know the line charge density and we want to find the total charge inside the system, so we can do integration where the total charge Q is equal to the integration of rho L dl. dl is the length, the total length. Let's say I want to find the Q just this part, at this part. So the dl will be from here to here. If I want to find the total Q inside the line, so I will integrate to the whole length. Something like that, integrations. Whether you want to find just a partial or all.